First of all, thank you very much for allowing me to present the latest update on our results on Epihunter absence at the Pipeline Conference. I'm very sad I couldn't make it, but at least I will try it in this way. I should get the next slide, but I don't know. Yes?
Yes, we can see the next slide.
Great, excellent. So Epihunter, obviously, I will talk mainly about validation of our Epihunter absence solution, but we really want to go beyond that. We really think that wearable EEG can help people with a brain disorder participate better in society by just showing what's going on in their brain. Well, it's not just showing, but trying to show what's going on in their brain. Next slide. I'm not going to try to put it. Because from the beginning we wanted to go beyond absence seizures, we built a platform where on top you can see that we focus on the user, on the person with epilepsy, and we build something that gives them value while they use it. Because we think if you want people to use whatever technology every day, it should not be there only because in 6 months or in 3 months they will see their doctor. It should give them value every day. So we use a wearable EEG device, we use an AI algorithm on the smartphone, and we will in real time give feedback on whether they have a seizure or not. And on top of this, we keep all the information in a diary for them, for their caregivers. But obviously it doesn't end there. So we also have a cloud platform where on one side, the doctor can monitor or see what's going on with their patients in monthly reports, for example. And we can even have group statistics or other data, which we can share with pharma companies or with governments or whomever is interested in an overview about what's happening. Next slide. Here you can see a person wearing the device. So it's the headband on the head with a small dongle here. And it's a typical situation at school for a person with absence epilepsy, where you can see a smartphone standing on the desk. There's one mistake in the picture because the mobile shows a red dot, which means there is a seizure going on, which is obviously not the case. But so both the person themselves and the teacher would be able to see there's a seizure, so they can ask whether they have to repeat something or whether everything is still fine, or they can just come back after the seizure is over. We're on the market in Europe, Australia, and New Zealand, and we collected over 20,000 hours of real-life EEG in the meantime. Next slide. But today I want to talk about our phase 3 validation study. So obviously the question is always, how good is this? How good are those wearable devices combined with AI? And thanks to the support of the Epilepsy Foundation, we ran a study in Boston Children and 3 other centers in Europe. So that's the country Georgia, not the state of Georgia. And it was a blinded study, which means we gave the hospitals the Epihunter device. We made sure it didn't make any noise or any visuals whenever a seizure was happening. And while people were having their clinical video EEG, because they might have had absence epilepsy, we in parallel recorded the Epihunter data, blinded. The hospital didn't know what was going on with the Epihunter data. We included a little bit over 100 patients, mainly younger age range 4 to 28. Next slide. Of those patients, 40 patients had absence seizures, all in total 364 absence seizures. We had 300 hours recording time. We had a median sensitivity of 93%. I must say we compared to expert ratings on clinical video EEG. So we looked at electrographical seizures because that's what we measure. But we compared what we measured automatically with what epilepsy experts saw in the video EEG blinded. We have a false detection rate of 0.5 per hour, but 65% of the patients didn't have any false alarm. And we had a median F1 of 0.82. And to continue the discussion that was just there about the difference between electrographical and clinical seizures, near the end of the study, we added in some subjects clinical testing. So when we do real-time detection, we have a mobile phone, so they have the mobile phone in hand. And whenever we detect something, we did switch on the phone, and it gives you a red button that you can push if there's no seizure at all. And this allows us to have real-time feedback on whether they can push a button, or so whether they're aware or not. And there we had 36 seizures included. We're 100% correct. So in 30 of the cases, it was an absence seizure. You could really see on the video the screen changing, and nobody pushing the button because they were having an absence seizure. And in 6 cases, you could see the screen changing and the people having a button. So this is a way to help, even with devices, to see the difference between a clinical and an electrographical seizure. Next slide. And I think that's also where we want to head from here. So we want to extend this behavioral testing, not just binary, do you have a seizure or not, but including some tests, because we noticed that in absence epilepsy, it's not being aware or not being aware, but it's very often being less aware or being more aware. And with having some automatic tests and measuring reaction rate whenever we detect a seizure, we can have more information about what's going on with the people with absence seizures. We're also looking beyond absence epilepsy for other non-convulsive patterns or syndromes, where we really think there's a value in having, on the one hand, real-time feedback, and on the other hand, better information for doctors or for pharma companies. Next slide. And I'm not going to run over all the names that were essential for performing the study. We're very thankful of all the collaborators, but we're even more thankful of the Epilepsy Foundation, because as I mentioned before, they supported us with a new therapy grant, and without them and without their support, it's financial, but it's also conferences like this where you feel that there's at least some people looking forward in the way a lot of people in the room think epilepsy care should be going. So thank you very much, and thank you very much for your attention.